Volume of revolution. Volume of revolution, pretty nice, easy topic, but it's new, like you haven't heard of it. So basically, volume of revolution, imagine you had a little function. I'll show you here.
That's what the universe looks like.
So imagine this was your little function.
Yeah, that's the most.
Okay.
So there is how it accelerates.
Okay, cool. So guys, thank you. So imagine he's in 2 dimensions. So 2 dimensions, this like would be, well, here's your function. And the area under it would be this lovely blue little area here. Imagine you took this little function and you rotated it 360 degrees around the x-axis. What kind of shape would you get?
What? A circle?
Yeah, if you took this area and rotated it 360 degrees around the x-axis, what would the shape look like? What would it resemble?
It was one you were skipping investigation.
Oh, we're coming back to it, yeah. So just doing an intro to... Okay, so back to you. So here's the area. If you rotated this area 360 degrees around the x-axis, what kind of 3-dimensional shape do you think you would get? Yeah, well observed. Yep. Kind of that, like a speaker. Kind of like a speaker, like a loudspeaker kind of thing. You know those megaphones? So to see, like, it's kind of this curve. This is an exponential function, obviously. Here's the area underneath the exponential function. And if you rotate it 360 degrees, so this is called volume of revolution. So volume of revolution. We're going to do a little investigation to sort of try to work out, a quick one, try to work out how do you calculate the volume of that, using the area under the graph, how do you calculate the volume of that 3-dimensional shape? So we'll carry out this below investigation to work out what this topic, volume of revolution, is all about. So here is a nice simple one. Consider a triangle formed by the line f of x equals 0.5x. What kind of function is this one here, f of x? Linear, good. Let's go to gradient. What's its y-intercept? 0. Yeah, because it's plus c. Y equals mx plus c. It's got a y-intercept of 0 and a gradient of? 0.5. Yeah, so it's going upwards. So that's why the line looks like this. So consider the triangle formed by this area here, by the function and the x-axis between x is 0 and x is 6. So what's our value of a?
0.
And our value of b? 6. Well done, yeah, exactly. And that's our little area there. They're making it the investigations with a nice simple kind of function. If you rotated this 360 degrees, what kind of shape would you get then, do you think?
A cuboid.
Okay. A cone, yeah. Why would it be a cone? It's hard to explain, isn't it? It just is. Yeah, so if you rotated that triangle and swept it around 360 degrees, you would make a cone, yeah. Okay, so copy and complete the table. Well, you don't need to copy it. And give the dimensions of the volume of each of the discs formed when the rectangle shown in the figure is rotated 360 degrees about the x-axis. The last row on the table has been completed for you. So that's talking about this little disc here. What shape is this disc? A cylinder. Yep. So this little disc here. So if you use a triangle, but if you just took this rectangle here, notice I've divided into little rectangles. If you took this little rectangle and rotated it 360, you'd make a cylinder, a flat cylinder. So they're saying between 5 and 6, what is the width? What is the height of the cylinder then? The height of the cylinder is this way? Yep. 1, yeah. So the height of the cylinder is just 1. So it's kind of like the cylinder is kind of sitting sideways.
Okay.
So its height's kind of more so that thing. Because here's the cross section, the circle is the cross section. And so the height... so the height is always perpendicular.
So the height would be from here to here?
Yeah, the height is always perpendicular to the cross section.
This part. Because that's the circle.
What did you pour?
Yeah, the height is that bit.
There.
This is mine, yeah.
Oh,
Okay, so anyway, so that's the height. The height is 1, because so that's how we got the height. See, the heights for all of them are just going to be 1, yeah. As you can see, all of these ones, they're just all going to be 1. So the height for all of them will just be 1. So feel free to just write in 1 for all of them. So this one, see, it says the height here, or the height is going that way. The height's always perpendicular to the cross section, and the cross section is the circle. What is the radius of this one here? So what would be the radius of that first cylinder?
6. No, I lied. 3.
3, good. Yeah. So what did you say instead? You said
So it's
the
the opposite of what I did.
diameter. Good. Yeah. Yeah. So it's going to be. So that's why that one is 3, because they're saying f of 6. If you subbed in x is 6, just by looking at the graph, we can see you can get 3. But also f of 6 is, remember f of x is 0.5,
It's 3.
and 0.5 times 6 is 3. That's another way to do it. We can see it. So these are all 1. Okay, so 4 to 5. 4 to 5. So notice which one did we put in 5 or 6 when we subbed it into the function?
We put 6 in.
Good, yeah. So for the next one,
We put 5.
put 5 in. Good. So what's 0.5 times 5? Like that.
2.5. But also it just goes up by 0.5.
Yeah, so you'll start to notice, yeah, you've seen the pattern. So the next one, yeah, like Bella was saying, will be the upper limit f of 4. So the function's 0.5x, so 0.5 times 4 is 2, good. And Bella's seen the pattern, so 1.5, 1, 0.5, got that. We've got it. How do you work out the volume of a cylinder?
Pi r squared h.
Good, yeah, pi r squared h. So we'd have to pop that in the calculator. So see, they did that pi 3 squared times 1. So we're going to have to do that for all of those. Pi 2.5 squared times 1 equals.
I hate this because I can't see English.
1 equals. I'm just filling in a few because I can't write on this board. I don't know the answers to these, by the way, so if someone want to tell me. No, notice they're doing them to basically 2 dp.
0.6.
This one's 0.63. 19.63. This one? Thank you, yeah. 19.63. Yeah, so let us know, because I don't know.
5, 6, 6.
Is that the next one? What was that, Bella, sorry?
12.566.
12.5.
Please.
What's happened again? Okay, you guys keep working them out.
12.566, 370.
Could you get this on 3 6
12
We're gonna do 4
The next
sig
one.
figs, so that is 4.
Yeah, 4 sig figs, which is probably going to be roughly 2 dp. But yeah, 4 sig figs is good. Oops. Okay. Oh, and what's that number? Or what's any of the numbers?
12.56.
Thank you.
5, 7.
5, 7, thank you. Anyone know?
7.0.
069, sorry.
6, 9, oh yeah, good. 4 sig figs, yeah. And the one above that?
There's 07.
0.142.
And there's 4 6 16.
Yeah, that's like 4 sig figs, yeah. Because yeah, you're right. And the numbers are getting quite small now, so we might end up with not enough, might not be accurate enough. Sorry, what was the next one, Bella? That one there?
3.142.
Oh yeah. Why is that?
Pi.
It's pi, yeah, because you end up subbing in 1 and 1.
I was thinking about pi this morning.
And the last one?
0.7854.
Yeah, that's right. Yeah, I said 2 dp initially, but realizing how small they're going to get, 4 sig figs is more accurate. So, well noted, Katie. And then, what are we doing?
We're about to leave.
No. Oh yeah, and then we find the sum of the volumes. We'll do that next lesson. That's okay.